It is already started. Okay. Let me introduce myself first. I'm Dr. Bunil Balabantaray from working as an assistant professor in the Department of Computer Science and Engineering. My research focused on image processing, robotics, and machine learning. We generally do some development with respect to the modification of the architecture of different machine learning and deep learning frameworks, and also we go on developing different robotic applications. And also I'm involved in robotics center which is running at NIT Meghalaya. Along with that, there is a robotics club. We also take care of certain training programs to different section of society. Recently, we have concluded one training program to school children of state Meghalaya. This is supported by the state government Meghalaya. So with this, I'll start my presentation. Let me ask you one question. What do you understand from fuzzy, the word fuzzy? Can anyone answer to this? What do you mean by fuzzy?
Yes, sir. Fuzzy means not clear.
Yes.
In Boolean values, we have only two values, 0 and 1. But in fuzzy, we have continuation of values. Means the
That,
values are not fixed.
that means whenever our mind is confused, right? To take a certain decision, we understand that there is a fuzziness, right? There is a vagueness in the particular scenario. So that kind of situation where you can apply this fuzzy logic to get a particular reasoning about the problem. So fuzzy logic is a method of reasoning that resembles human reasoning, and the approach of fuzzy logic basically creates a way to take a proper decision without involvement of human, without considering any digital values like yes or no. In the conventional logic, we understand there are two kind of rough set theory and fuzzy set theory. Along some mathematics teachers are there, they know it better. So whenever we have a general set theory, that is, we say crisp set theory, in that case, we understand either a particular element belongs to a set or doesn't belong to a set. But we cannot decide whether in between the belongingness and not belongingness to a particular set, it doesn't decide, right? So we'll take an example. Let us consider one example. Suppose there is a beautiful woman who is going in front of us. We generally say how beautiful she is. To me, she may be beautiful, but to other, she may not be beautiful. So how do you define this beautiful, particular word beautiful? This is one of the fuzziness example we have. Another also, in general, if you ask a particular person of age 40, are you young? Definitely the answer will be, yes, I am young. Similarly, if you ask to a person having age of 50 plus, she or he will be answering, yes, I am young. So this young is a word which is very confusing in nature, because it depends on the perception, how you perceive at the personal level, how do you calculate the youngness of a particular person. So such kind of scenario requires a particular logic through which you can take care of such scenarios. In my discussion, I'll be having all these examples throughout, along with some industrial example I have. So fuzzy logic is a form of many-valued logic. It deals with reasoning that is approximate rather than fixed and exact values. As I told, the crisp set theory, what we have, if a particular element belongs to a set, we understand it is an element of that set. That means the belongingness is 1. If it doesn't belong to that set, the belongingness is 0. So that is only two-valued logic. So crisp logic, which we generally know, the set theory, that is a two-valued logic. But in case of fuzzy logic, it is a multi-valued logic. I'll also discuss with example what is multi-valued logic. In contrast with the traditional logic, where binary set, as I told, two-valued logic, true or false, right? Either belongs to or doesn't belong to. So this is the traditional logic, traditional set theory we have. So fuzzy logic has been extended to handle the concept of partial truth. That means whenever there is a confusion, in that case, there is a partiality, right? Whether it can be true or false, that we don't know. We are not sure about the result. In that case, what we understand, that's a partial result lying behind that. So in that case, fuzzy logic can be applicable. Considering a particular example, if I make a teaching to a particular children, that you write A in this particular symbol, right? By putting through different panes. So A, particular character A, the child has to recognize that this kind of symbol is a particular A. So in this case, what we have, we need to teach them, you need to teach the children how to recognize the character. So suppose say while drawing the particular symbol A, she or he may have missed some portions, right? It may not be continuous in nature. In that case, how do we recognize that this is A or something different? That means some portions of this A symbol is missing. So in this case, what we have, we need to find out, we need to recognize that this is A or something different. Again, linguistic variables, what do you mean by linguistic variables? Suppose you are all, you are having an AC and you are calculating, you are finding out the temperature is high, low or medium. You are setting the, accordingly you are setting the room temperature, or you are setting the temperature in AC. So linguistic variable, I mean the variables which we generally use in general life, like high, low, medium in case of AC. In that case, this high, how do you define high? Low, how do you understand what is low? So this range of values, how do you define for such kind of variables? So these are the linguistic variable that will be managed by the fuzzy logic very efficiently. So the father of fuzzy logic who has developed this is Professor Jade. Basically, he has developed, he has given the concept in 1965 to control certain industrial applications, right? Many fields basically we are using fuzzy logic. So to control that, he has suggested some example. So that also I'll be taking care in my discussion. So these are the history. I am not going to the history much details. I'll be directly going to the particular portions where the set theory and different operations are involved with examples. Yes, fuzzy logic. As I asked you the question, the term fuzzy refers to the things which are not clear, or basically it is vague. So in the real world, many times we encounter a situation when we cannot determine whether the state is true or false, or their fuzzy logic. Here the fuzzy logic provides a very valuable flexibility in reasoning process, in decision making process. So in this way, we can consider the inaccuracies or uncertainties of any situation. That means if you apply the fuzzy logic, it can make accurate decision up to certain extent. So also it can avoid the uncertainties. But in case of Boolean system, I mean all the computers are working on Boolean system, digital values, that is either 1 or 0. So in that case, only we have a two-valued logic, right? So there is no intermediate value is present. That is, we have already discussed, that is either partial true or partially false. A scenario, I'm just giving this example. Is it cold? In case of Boolean logic, what do you understand? In case of crisp set theory or general set theory, which you know, right? So in that case, either it is cold, we'll say the answer will be yes or no. So that means two valued is there. So, but in case of, in general life, we face the below one. In general life, whenever you ask to somebody that is it cold, So the answer may be, yeah, it is little bit cold. So in that case, how to define this little bit, this particular word? Because whenever a particular reasoning process is there, we need to model it in mathematically. So whatever words naturally we are using, very much cold, little cold, very less, right? It is medium like that. So how to define, how to represent such kind of variables in mathematics? So that is the beauty of fuzzy logic. It gives this approach to represent such kind of terminology to represent mathematically. So this is the fuzzy logic example on differentiation between these two kind of logic. Here, fuzzy logic is a superset of Boolean logic or conventional logic, which handles the concept of partial truth. If I give you the exact picture, the circle which is inside is the crisp set theory or Boolean logic, but the circle outside is the fuzzy logic, because in fuzzy logic we also take care of the Boolean logic along with multi-valued logic also we consider in fuzzy. So that's why it is a superset to crisp set theory. Now it's a very beautiful example that let a 100 ml glass contains 30 ml of water. Then we may consider two concepts, either empty or full. In Boolean logic, there are two options for answering to such queries. That is, either the glass is half full or glass is half empty. But in case of fuzzy logic, one can define it is 0.3%, right, or 30% full, or 70% it is empty. That also we can answer in fuzzy logic concept. Most importantly, we understand what are the fuzzy is all about, how it differs from crisp logic. But the most important thing is, whenever we are going to develop a fuzzy-based system, we need to understand what are the components to be present in the fuzzy logic system. Basically, the architecture tells about 4 components. There are rule base, there are fuzzifier, there are inference engine, and there is a defuzzifier. So whenever we talk about the architecture of fuzzy logic system, it comes into picture different 4 components. Let me tell you one scenario through which you can understand easily. Whenever a children is going to learn about the alphabets of English, what you are doing, you are trying to make him practice that you write this way is A, that way is B, like this you are going to practice. So during practice, that means the training what you people have understood in the previous sessions. So during training, what he is learning, the learning is he is understanding the different symbols of different alphabets, how to write, what is the exact symbol of A, what is the exact symbol of B. So what he is doing, he is creating a database, he is creating a knowledge base, he is collecting all knowledges related to the alphabets. So that is called the knowledge base. And knowledge base is comprising of certain kind of knowledge he has acquired during the training phase. So in knowledge base, basically what we have certain symbols and the associated rules. So later on, after learning this A and the different alphabets, later on if you ask by drawing a symbol of A, you ask him what is this symbol. So he is immediately answering that this is A. So this is the scenario how the fuzzy logic system is working. So what the child is doing whenever a question is being asked, which he has already been trained. In that case, we are giving a question that beta, you just find out which symbol it is. So what fuzzifier does? Fuzzifier is going to find out the membership. It's going to find out that what kind of symbol I have learned during my training phase. So it is going to take the help of the knowledge base, right? Here I have written only rule base. That is basically the knowledge base. I am coming to that picture particularly. What is knowledge base? So knowledge base contains these symbols, all the alphabet symbols along with the rules. If this is the symbol, that means the type of A, right? If this is the symbol, then I have to answer this is A. If this is the symbol, that I have to answer is B. So in knowledge base, it is containing some kind of symbols along with the associated rules. That's why its name is also rule base. So Fuzzifier takes the input and take the help of the knowledge base. Then once the knowledge base gives the exact result to the Fuzzifier, then Fuzzifier go to the inference engine. So inference engine, what it is taking, what input it is having, it is inferring, and also it is comparing with the knowledge base result, right? Then it is finding out what exactly the input is, whether it is A or B, right? So again, it is going to the decision part, that is defuzzifier. So there it is going to find out the result that this is A. So this is the approach of the architecture is all about. Here for children cases, of which example I have given, this is working very perfectly in case of character recognition, in case of object detection. All these cases also applicable for this kind of architecture. So let me go to the fuzzification process. It is used to convert the inputs, and that is the crisp numbers, into fuzzy sets. And crisp inputs are basically the exact inputs measured by the different sensors. That means sensors here in our case is our eye, right? So because we are reading this particular symbol which is given in the task, and it is passing to the control system for further processing. Similarly, inference engine is taking care of determining the matches between the input and the stored knowledges in the rule base, and giving you the exact output, that what it is exactly the comparison output it is giving to you. Then defuzzification is to again reconvert, right? It is giving you the standard, the format the input is all about. So the defuzzification process is also a very important phase of the fuzzy logic system. Here, there are I was talking about the rule base, right? Fuzzy logic usually uses if-then kind of rules. So what it is all about? If the temperature is very cold, then stop the fan. If the temperature is cold, then turn down the fan. If the temperature is normal, then maintain certain level. If the temperature is hot, then speed up the fan. Let me give an example. Suppose a mango, having 2 mangoes is given to you. One mango is having green color in the outer part, and another mango is given which is in yellow color. So the question is being asked, is the mango ripe? So what you understand? Basically the color of the mango in general, taking a decision, we can take a decision based on the color that it is ripe or it is not ripe. But nowadays, though it is the color of the mango is yellow, but still it is not ripe. So there is a confusion, right? So that confusion can be considered, can be represented in a if-then formula, so that you can easily take a decision, or you can easily take an action. Similarly, the example of young, the man is young or not. So that also can be considered, can be represented in if-then rules. Let us take the comparison between these two kind of set theory. Classical set theory basically is having different sort of elements. Suppose say A is a set containing A1, A2 up to n elements, which I can represent in a characteristic function format. That is, suppose say mu A is the membership value of this element X, right? is equal to 1 if the element belongs to that set A, is equal to 0, that the membership is 0 if it is otherwise. That means if X doesn't belong to A. So that means in a classical set theory or rough set theory, what we have, as it is a two-valued logic, the membership about an element can be categorized either 0 or 1. Consider a particular example, the prime number set. X contained in X is prime number, right? So in a fuzzy set theory, basically here the prime number set, what we have, either 2, 3, 5, 7, 11, so and so. So if I take a particular element 5, whether 5 belongs to that set or not, I can have only either 1 or 0 answer. But in case of fuzzy set theory, this will be defined with a degree of membership. Here the characteristic function is containing only membership, either belongs to or doesn't belong to. But in case of fuzzy set theory, it will be a degree of membership. Degree of membership means it is having a range of values in between 0 to 1, including both. So that's why, as I am telling, including both, 0 and 1 can be included in case of membership, degree of membership in case of fuzzy set theory. That's why fuzzy set theory is a superset of crisp set theory. So here, A is being defined as X such that, all of you, anyone is asking anything? There is a noise coming. So here, in case of fuzzy set theory, the elements is being represented in a ordered pair form. Here I can just I can put a particular point here. Let me put here one box. A is a set which is being defined in this form: X, comma, mu AX, right? So here I'll be basically using the different symbols. Sorry, here the mathematical, this particular system doesn't have this particular form. So here to make you understand that this mu, I'm just writing mu small. Mu A of X. So this is the order pair we generally have in case of fuzzy logic. This is the order pair. I'm just putting it in a order pair form. So here, this is the order pair. That means in case of fuzzy set theory, what we have, X comma mu AX. That means here this is small a, I have written, this is capital A, X. But in case of Boolean logic or classical set theory, this is just a element, X will be written. But in case of fuzzy set theory, the elements is being represented as an order pair, X comma mu AX. That means the element must be associated with its membership, degree of membership. So that is the concept behind the fuzzy set theory, how it is different. A crisp set, all of you, as I have already told, member or not a member. But in case of fuzzy set, it is a fully a member, then the membership value, degree of membership will be 1. Not a member, the degree of membership will be 0. And partial member, right? So maybe if it is coming within the boundary, in case of Venn diagram, you can understand that it is coming within the boundary. So in that case, it is a partial member. Now we will come across the different operations we have. So classical set, all operations all of you are aware of. I'm not going in much details, but the representation scheme I am using differently, which you may not have used. So this I'm just putting that with a characteristic function representation scheme for a crisp set. I'm using mu ax, the degree of the membership function, mu ax, that is element x membership. I am just calculating is either equal to 1 if x belongs to A, 0 if the x doesn't belong to A. So the operations behind this particular kind of set theory is same as all of you know. Union A union B, if there are two sets A and B, the union can be considered to be X, such that X belongs to A or X belongs to B. Intersection, all of you know, intersection B is equal to X, such that X belongs to A and X belongs to B also. So this is a example of logical AND operator. Complement is, all of you know about complement. X doesn't belong to A, but X belongs to the universal set. Difference, all of you know. So these are the basic operations of classical set theory. I'm not going much details about this. All of you know it. But in case of fuzzy set theory, how do you represent? As I told, it is an order pair. So in the particular set, this tilde symbol I have used to represent a fuzzy set. A is a fuzzy set here. So this is the particular order pair x comma mu a of x. So this is the element such that x belongs to the universal set X. So fuzzy set is having a degree of membership between 1 and 0. The fuzzy sets are represented with a generally tilde symbol to distinguish from general set theory to fuzzy set theory. And the partial membership basically exists between the range, that is either 0 to 1. So this is the representation scheme of fuzzy set. The union of two fuzzy set will be calculated based on the membership, degree of membership. So here, if you consider two set comprising of certain elements, and if you go for finding out the union, then suppose say in both set 1 is an element. In the first set, the membership of 1 is 0.3, and the second set B is having another element 1, which is having membership value, suppose say 0.7. So what is the resultant membership value for 1? So resultant membership will be calculated based on maximum of mu ax and mu bx. So 0.7 is the maximum value. So in the resultant set, 1 will contain the membership value is 0.7. Similarly, intersections we have is the minimum value. So in the same example which I told, for one element 1, the membership value is 0.3 and 0.7 in A and B set. So 0.3 will be considered in intersection. Similarly, complement. In case of complement of a particular set, fuzzy set A, you can calculate by subtracting 1 minus the membership to get the resultant membership of a particular element. So these are the basic operations, and all other rules of set theory is holding good in case of fuzzy set. Now, let us have a particular example. Here, the name of the person and the age is being recorded, and the degree of membership. Here I have, it is young or not young, right? So in case of crisp set theory, suppose say I have a restriction. If any man between the age from 20 to 40, I consider is a young man. In that case, in the case of crisp set theory, suppose say Sally is a particular person which is having age 5, Jenny 18, Kristen 25. The degree of membership here, according to my constraint, I consider Kristen is only young, so the membership is 1, and all others are not young, so the membership I consider to be 0. Similarly, in case of fuzzy set, I have Sally, I have Jenny, I have Kristen having the same age which I have taken before, so the degree of membership I am calculating. So here, as the diagram you can easily visualize, it is gradually increasing, right? It is gradually increasing. At certain point, it is going to be the membership value will be 1. So this gradual increasing, that means this is the fuzziness, this is the fuzziness part. That means here I can have 0.3, 0.2, like this it is having, right? So Jenny is having the age of 18, so the membership degree of membership I am considering is 0.7. But in case of crisp set, it is not like that. It is either 0 or 1. Let us go to the membership function. There are different mathematical functions being used to support this membership, degree of membership. Here I have 3 parts. One is core part, support part, and boundary part. So a membership function is a mathematical function which defines the degree of an element's membership in a particular set. So core is the region which is characterized by full membership in a set. That is the membership value, the degree of membership will be 1. Support is basically the region characterized by the non-zero membership values. That is mu or x is greater than 0. So in the diagram it is very clearly written that which is the support. And similarly the boundary is the region which is characterized by the partial membership in a particular set. So this is the boundary, right? This particular region is the boundary for what I understand, right? So that is either in between 0 to 1, what is the membership value? So that is the boundary of this particular fuzzy set. Sorry. So here, adult, a particular person is going to be adult, right? How do I define that? So if the age of a particular person is less than 16, he is not adult. So again, I have framed a particular formula. Age of a particular person minus 16 divided by 4 is a particular adult. Or if the age is between more than 20 years is found to be fully adult, right? So that in that case, how do I calculate in that case? So in such cases, what I understand, fuzziness is coming into picture. That's why all of you can understand there are 3 values, right? 0, these values, and these values. So 0 means if it is less than 16 years, 1 means if it is greater than 20 years. But in between that, what is the value? 16 to 20, right? So that I need to calculate the membership. So this is the formula, right? This is the function I can say which is going to calculate the membership, degree of membership. So that anybody can define according to the applications. It is not fixed for all such cases. So fuzzy logic, basically we have discussed different terms of fuzzy logic, right? What I'll take one industrial example. In case of an industry, if you talk about suppose a steel industry, there are different hot chambers. In case of hot chambers, the chambers should be properly maintained with certain degree of temperature. So in that case, what we do, we use different variables, right? Here freezing is a variable, cool is a variable, warm is a variable, hot is a variable, right? So in case of industrial automation, so as it is automation, automated kind of concept is being used. So in that case, to maintain certain degree of temperature of the hot chamber, what we do, we are putting a sensor, and the sensor is reading the room temperature. If the temperature is going down up to after certain level, the heater is going to start, right? So this is the way how the industrial automations, the sensors are being employed to read the particular room temperature and maintain the room temperature of that hot chamber according to the condition we have given. So here, in case of freeze also, you can relate this example with your freeze also. You can relate this example with your washing machine, because I have seen some of the speakers have taken the washing machine example. I have also that example here. So here, if the temperature is up to 30, then I can say it is somehow freezing temperature, freezing temperature level. But whenever it is reaching 30, again the cool level is coming up, right, into picture. So it is gradually increasing the cool level, right? So whenever it is reaching 50, it is purely cool, right? So freezing is going down. It is the freezing variable is at 50 is becoming 0. The membership is becoming 0. Similarly, cool is reaching high and it is gradually decreasing afterwards. Then warm is going to be increased, right? So this is a fuzzy word. These are the four variables, right? These are the four variables which I define based on the requirement. That what is the temperature limit or temperature level, so that I can say it is cool, it is warm, it is hot. So based on that, I can define these linguistic variables. So most importantly, to utilize the fuzzy logic, we need to understand what are the linguistic variables are to be used and how they can be defined. So as I have already told, different operators, right? We have already discussed about the different operators. Now here, just in a fuzzy logic, in a pictorial form, I'm just showing you what is the basic operations. Logical AND, I'm taking one example. So suppose say this is a set A and this is a set B, and fuzzy, in case of fuzzy logic, the AND operations will be this, which is being calculated based on the minimum value, right? So if you put in a graph paper, you can easily understand how I'm getting this particular value. Then I'll go to the logical OR. The same kind of concept is basically used. Similarly, the NOT operator will be having, and the implication symbol, all of you know, right? So the same kind of operations we are generally using to find out the result of different operations we'll be using. Let me tell you one specific example before going to the next part. Suppose one example, all of you have pen and paper, right? So you please write a sentence. All of you please write a sentence. Writing, because this I have not included here, because generally I take my classes automatically, right? The examples which comes to my mind at that moment I am taking. For all students, write a sentence. I'll be discussing about that particular example. For all students belongs to computer science must know Python. Must know Python. Sam, this is the first sentence all of you have written. Anybody has not written that sentence? All of you have written.
Can you repeat, sir, once? Although we have written, please, can you repeat?
Participants, yes or no?
Sir, please repeat once only.
Participants, yes or no?
Yes, sir. Written, sir.
Yes, sir.
Actually, your voice is not
Yes.
Somebody is asking to repeat the question.
Okay. For all students belongs to computer science must know Python.
Yes, sir. It was all students belong to computer science must know Python.
Yes. So for all, you mentioned for also. Huh? So Sam is a computer science student. Sam is a computer science student. Can all of you have written this second sentence? Sam is a computer science student.
Yes, sir. Sam is a computer science student.
So now tell me, what will be the conclusion based on these two sentences you will get?
Sam is a computer science student and he knows Python.
Sam knows Python.
Should know the Python.
Yes, Sam
Must
knows
know.
Python.
Yeah.
Shyam must know. It's not ki he knows, he must know, but it's not clear whether he is knowing or not knowing.
He must know,
Yeah,
sir.
one by one, so that it will be, because I want everybody should interact and to understand, because we are going to handle the natural languages, right? With the help of fuzzy logic, right? So here the question is, first sentence is, for all students belongs to computer science must know Python. So this I say is a premise for me. That means it is given. In case of mathematics, we generally say, na, given x is equal to, given that x is equal to this value. So it is given for us. What is the second thing? Sam is a computer science student. That is also given. So based on these two sentences, what I can understand, Sam knows Python. Some of you also have told Sam must know Python, right? So all of you know this one. How mathematically I should represent this? How mathematically I should represent these particular sentences? Let me change the sequence of the sentence, which will be helpful for you to model it mathematically. First sentence, I'm just making the changes in sequence. Shyam is a computer science student. Second sentence I'm writing, for all students belongs to computer science must know Python. I'm just changing.
Sir, your screen is not visible, sir. You are sharing, sir?
No. I'm just telling, because this is the exercise we are doing, right?
Okay.
So I'm not putting anything in the slides. So
Okay.
I just change the sequence. All of you clearly try to visualize what I'm telling. I'm changing the sequence of the sentence. That first sentence I consider now, Shyam is a computer science student. Second is, for all students belong to computer science must know Python, right? So these are the two given sentences I have. Now I am repeating again. Now I'm converting these two in a different form, so that it will be easy to understand me. It is easy to find the reasoning, find the result. So the first sentence, Sam is a computer science student, no doubt, no issue, is given. It's a very clear sentence. Second sentence, I'm just putting it in a mathematical form, in a sentence which will be easy to develop in mathematics, right? Which is easy to model in mathematics. For all x, if x is a student in computer science, then x must know Python. See, same sentence, nothing changed I did. Only the way I incorporate that sentence is different. Again, I am repeating the second sentence. For x, for all x, all of you know the symbol for all x, right? If x is a computer science student, then x must know Python. So this is the second sentence, right? Now, all of you, once if you have written these two sentences, just put a underline, means put a line after that. Now, these are the two given things. What I understand, two given things. Here, the first sentence is the premise. That means it is a fact. It is true. Sam is a computer science student. So that I say it is a premise. Second is, I convert it into in a if-then formula. If-then rule. Yes or no? Can anybody tell me? Yes or no? I convert that sentence into a if-then form.
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
So what I did, I convert the same sentence without changing the meaning, without changing the knowledge behind the sentence. I changed it in a if-then form. Right? So that this second sentence I can term as a rule. So first sentence is the premise, second is the rule, and the as I have told, give just draw a line after that, conclusion. So what conclusion I'll get? That Sam must know Python. So what fuzzy logic system is talking about? Fuzzy logic system is telling you take the input. What will be the input? Input will be some premise, some rules, right? And you compare with the knowledge base. As these two sentences are given, that means they are given. That means they are true. So the reasoning, the conclusion, I can easily find out that Sam must know Python. All are getting this particular concept?
Yes, sir.
Yes. So this kind of rule is called modus ponens rule. This kind of rule is called modus ponens rule.
Sir.
So what modus? Yes. Yes, anybody is asking anything?
Modus, what are you?
Yes, modus ponens.
Sir, can you repeat again?
Yes, it is there in the PPT. You can check.
Okay.
Modus ponens rule.
Okay, right.
Understood? So,
Right,
modus ponens rule, what it is talking about, let me draw you one kind of set of rules here, so that you can visualize what kind of format we generally use in modus ponens. P, let me make it bigger in size. P implies, see, I'm just writing in a different way so that we can understand, right? So here, so given P, that means P is a particular sentence what you have taken, given. And then there is a rule. If P, then Q, given. Then what will be the conclusion? Conclusion will be Q. Yes. So all of you can prove it using set theory. Yes or no? Because P is given, it means the truth value will be true. Sorry? Anybody is asking anything? Okay. So if P is given, that means the truth value of P is true. You should take true only, not false. And P implies Q is given. That means the truth value of P implies Q also you should take as true. Are you getting my point? So in this case, if you take this truth table, P table and P implies Q table, you will definitely find only Q will be having the truth value true. Okay, so in that case, the conclusion is coming to picture, that is Q. Let me tell you one of my PPT I have. Actually, I don't know. I'm going to different sections of the fuzzy set or artificial intelligence, I can say, because I am taking discrete mathematics also. So in that case, I don't know whether it is there or not. Let me check once so that I'll go to my discussion. Otherwise, in the next, I have another session also. I'll be discussing there also. Otherwise, it must be there. Yeah, it is not there. Okay, I'll give you this one in the PPT. I'll include it. No issue. So what I wanted to tell you, there are propositional logic, right? Beyond this fuzzy logic, there are propositional logic and first order predicate logic, right? So whenever a sentence is given in English like languages, you can convert it into logical form, right, which will be helpful for representing in a mathematical model. So that is the way we need certain kind of rules. So modus ponens is a kind of simplified rule which will help us in fuzzyifying a particular problem. So this is the one approach. Now let me go to the applications domain of fuzzy sets. Here we have a lot of applications. So basically in control system designing, some of you are asking regarding robotics, right? In the control system of robot, we can design using fuzzy logic. And as all of you know, there are different washing machines you are using, vacuum cleaner you are using, in anti-skid braking system, all of you have in your cars, transmission system, control of subway system, unmanned aerial vehicles, right? Unmanned helicopters, right? So all these are the different kind of applications of fuzzy logic with respect to development of control system. Let me take a certain example. In fuzzy logic, basically here I have a industry example which I have already told to you, that we have a problem, change the speed of a heater fan based on the room temperature and humidity. So we need to read what? Room temperature, we need to read humidity of the environment, right? So these two things we need to read. So temperature of the control system has 4 settings. We have to, these are the linguistic variable we need to generate, right? It depends on you that how you can consider how we can develop the linguistic variables. Similarly, humidity I have defined using three different linguistic variables, low, medium, high. Then we define this fuzzy set. So humidity, if this is this much, then temperature I have this much, right? Temperature level I have this much, that is 4 variables. Now I need certain operations to get back this fan speed. So this is my input, this is another input, I'm getting the result, which is the fan speed. So this is a kind of example we have generally. All of you know the max min, the different kind of operations. One of the important operation is max min composition rule. If you are in mathematics, you know this max min composition rule. All of you, just I'm giving you one picture of max min composition rule. Here, this is the set of variables for humidity. These are the set of variables for temperature, right? In case of max min composition, in general, if I make a product, right? So low and cold, right? Low and cold, there is a pair. Low and cool, there is a pair, right? Low and warm, there is a pair. Low and hot, there is a pair. So I need to find out the membership value of the such pairs, right? So these membership values I can calculate based on max min composition rule. So first of all, I'll take the maximum of these two membership values, low, cold, right? Then low, cool, the maximum. Then I'll take later on the minimum one, right? So that is all about the max min composition rule, which is being applied here. Now, in case of washing machine, this example actually during my studentship, I learned this example. Suppose you have a washing machine, and how to calculate? Instead of going to washing machine, let me ask all the beautiful teachers are here. Here, so many lady teachers are there. I just simply ask a question: how do you know how many oil you need to use for a particular, if you are going to fry certain vegetables? How to know? This is the practice you have learned from your mother, right? From the environment. Based on your expertise, you can understand, yeah, this much I have only 1 kg of potato I need to fry, so I need 100 ml or 50 ml of oil. So this is the training phase you got. During training phase in your life, you got that this is the thing. If 1 kg of potato is there, I need to fry, only 50 ml of water, 50 ml of oil is sufficient enough. So based on that experience, you are going to cook, right? So this is the way how our washing machines are working in such kind of scenario. So what we have? We have a sensing. Right, this is a circular kind of thing, all of you can easily understand, right? So fuzzy logic of washing machines are getting very popular. Why it is? I am coming into the particular concept. Suppose you have the cloths of 5 kg, right? Because it is being we need to find out the numerical values, right? Here I consider the weight of the dirty clothes. Then what is the percentage of the level of dirtiness? Weight, then percentage of dirtiness I am calculating. Then based on that, I'll find out how much detergent I need to use. So suppose say I have 5 kg of cloths which are dirty. I have the dirtiness is 30%, and the amount of detergent I am using, suppose say 100 gram. And then what is the next thing I need to think of? That how many time it requires to wash? How many time it requires to wash? So if the speed is, suppose say 60, 30, 40, because there are different levels, right? In case of washing machines, if you have a low, medium, and high. If you will be using medium one, how much time it requires to make it clean? So this is a condition. This is a scenario where yes. My voice is coming to you all.
Yes,
sir.
Yeah.
Yes, sir. Yes. Yes, sir. We are getting you.
It is already too late for genetic algorithm. I'm not going to finish the genetic algorithm today. In the next session which I have, I'll be going to the genetic algorithm portion. Let me give you some insights into different propositional logic and predicate logic, which is useful for fuzzy logic representation. Now here, let me give you this particular insight. So whenever we are going to develop a particular inference engine, generally inference engine is an important part of fuzzy logic system. In that case, we have different kind of inference procedure, right? Inference procedure, what I mean, one of the example is modus ponens is a inference procedure or inference rule. So logical inference is basically used to create new sentences that are logically derived from the given set of given set of sentences or inputs, and the inference rule is said to be sound enough if every sentence X produced by an inference rule operating on a knowledge base globally or logically, they follows the all sort of procedure of knowledge base, and it is said to be complete if suppose say I'm giving a particular example of character recognition. Suppose one A I'll draw, right? That A, which is some part missing, in that case, my system, if it can able to recognize that this is A where some part is still missing. In that case, if my system can do the inference, then I can say it is complete in nature, right? So this is a kind of a different inference rule. Here we have the modus ponens. I have already given the example of this. Then after that we have eliminations, we have negations, we have a resolution, right? Let me come to the resolution part, which is much important in case of washing machine applications. Suppose there are 4 linguistic variables, right? And we are having a problem of making our cloth clean. In that case, what we are doing, we are relating all these linguistic variables and their membership value we are finding out. Resolution, what does it mean? Resolution is the conclusion, right? All of you have different meetings, and the meeting resolutions you are finding out what you have discussed, what is the findings of the meeting. So in case of fuzzy logic, we have also resolution principle. Resolution principle, there are different varieties of resolution principle, but I'll take one example. In case of binary resolution, suppose there are two, let me give you one example. Suppose there are two sentences. P is there, P or negation P is there. So two inputs is given to you, right? What will be the conclusion you will find? Let me change it to Q or negation P. So P is given and Q or negation P is given. In this case, the resolution is being applied. That means P resolution is being applied with a combination, right? You can say it is a union of.
So a lot of disturbance was coming. Now it is
all participants, those who are making mic unmute, please unmute it. Making mic mute, please make it mute so that other can listen properly. So with this, actually, the time is already over. I am not going to go for this genetic algorithm, which I'll be completing in the next session. If any questions related to fuzzy logic and applications of fuzzy logic, I can be happy to answer you. Any questions on fuzzy logic? Any questions on fuzzy logic, all of you?
Yes, sir.
So, okay, with this, we'll come to an end of this session.